I have rewritten it a little bit, so that's the result of the second step. This is our clever trick, and here is the extra equation that came from this clever trick. All right, so in the next step, we are going to form, well, it's also quite clever, so we are going to form a system of algebraic equations, of just usual linear equations. Algebraic equations. Here is how. We are going to substitute this y prime and y double prime into the differential equation. So let me just find it. So y double prime plus 6y plus 9y. So y double prime plus 6y prime plus 9y is supposed to equal to t squared, but at the same time, what is it going to be? Here is y double prime. Yeah, get this correct. Here is y double prime. So let me write it as follows. I'm going to write u1 prime times t e to the minus 3t prime first, plus u2 prime times e to the minus 3t prime, plus u1 t e to the minus 3t double prime, plus u2 times e to the minus 3t double prime. And so that's my y double prime. Now I'm going to write y prime, and I'm going to write it here. So plus, I'm going to have u1, and we're supposed to have a coefficient of 6 here, 6 times y prime. So I'm going to write it now 6, and now I'm just copying this, t e to the minus 3t prime, and plus, of course, in the same way, I'm going to have u2 times 6 e to the minus 3t prime here. And so this is my y prime. And plus 9y. So here is my y. So I'm going to write it as u1 times 9t times e to the minus 3t plus u2 times 9 times e to the minus 3t. This is my y. And this whole thing is supposed to be equal to t squared. But notice that the sum of these three terms, we can take out u1 here, and the remaining thing is the result of substituting the function t times e to the minus 3t as y into this differential equation. And recall that these two functions, t times e to the minus 3t and e to the minus 3t, they were chosen as solutions of the corresponding homogeneous differential equation, which means that if we substitute this as y into the left-hand side of the differential equation, then we get 0. So this whole thing is y u1 times 0, which is 0. And this whole thing, by the same logic, is u2 times 0, which is 0. Right? And this must be equal to t squared. But this part is just 0, so the remaining part is this. equals t squared. Well, at the same time, recall that we have this equation, so u1 prime times t e to the minus 3t plus u2 prime times e to the minus 3t is 0. And now, together, these are actually linear algebraic equations in unknowns u1 prime and u2 prime. Well, let me reorder the equation. So this is the first one and this is the second one. So this is how they actually appeared in our work. So we first derived this equation and then we derived this equation. Then the matrix of this system of equations is, I will write this first, t e to the minus 3t, e to the minus 3t, t e to the minus 3t, prime, e to the minus 3t, prime. Well, and you see that this is the Wronskian matrix. So the determinant of this matrix is precisely the Wronskian of two functions, t e to the minus 3t and e to the minus 3t. But these two functions were chosen so that they form the linearly independent solutions of the homogeneous equation. So which means that the Wronskian is non-zero, is not zero for any value of t. And for instance, it means that this system of equations in unknowns u1 and u2 prime has a unique solution.